Right, welcome back, Science 7. Today we are going to go through a particle model of matter quite in detail. Last time we didn't go through as detailed explanation about particle model, especially when it comes to different physical phases like solid, liquid, gas situation, and we are going to go through that in detail today. So have that in your mind. Today we are going to go through a little bit of what we covered last lesson at the very end because we rushed things through about some of those basic assumptions to use particle model. First of all, the reason that we are using model. Okay, there you go. Pen. We are using model because some chemicals are too small to observe. Even using microscope, like molecules, water molecule, H2O. Then in that situation, we use two-dimensional drawing or three-dimensional structure that look like Lego pieces, and we are using those. And models always help us understand about physical changes and later chemical changes too. In order to use the particle model, there are 4 rules that you need to understand, and you need to memorize these. Number 1, all matters are made up of extremely tiny particles that you cannot observe. It's a hypothetical. Hypothetical means we are kind of assuming a certain things exist. In this case, we're going to use tiny little red ball or any type of color too. Because of this limitation, I'm going to just erase. There you go. Hypothetical. You can pause the video too. The tiny particles are always in moving. And this is quite significant. Because that means whenever things are moving, I want you to understand that it has kinetic energy, which we're going to talk about it more too. Any moving matter have something called kinetic energy. Kinetic means literally moving, so moving energy is what you can think of. Adding heat to matter makes the particles move around faster. So you will notice that when it comes to solid, liquid, gas is the one that move around the fastest and spread out the furthest. And the particles have space between each other. So what I mean by that is, if I have one particle, the next particle, there is always some kind of a distance between. Even if it's a solid, even though that distance is quite tiny. So have that in your mind. So let's go through each of the example. I'm using water as an example. As you may notice, the one that you see over here, I want you to put solid, in the middle liquid, and the last one gas. And there are a few things that I'm going to go through in terms of physical structures and physical property, not about the chemical properties. Solid. Think about ice. Ice, sugar cube, salt, table salt, anything like that. Solids have particles that are arranged in regular and repeating pattern. And as you may notice, it looked like a table even. I have horizontal rows and columns. You can think it in that way. And every single chemicals generally have a repeating pattern to become a solid too, even if it's different chemicals. Solids are held solids are held very firmly. All right. So solids are the one that generally do not change its shape even though these material are put in different container. I want you to put hard to change the structure because they are having really arranged and solid, I'm sorry, arranged and very tight formation. You can think it in that way. And the type of the movement that solids have is vibration only. So what I mean by that is this. Imagine this is a very poor form of a table. Think about the table that you're sitting on. So this is a tabletop. Imagine you are hitting a top of the table. Then you will notice that I'm gonna demonstrate using my kitchen table over here. As you may notice, there is a sound. And as you may feel that there is a vibration occurring to the part that you hit, that's going all the way to the other sides too. So solid have an ability to vibrate. This is one of the reasons why when it comes to earthquake that we're going to learn in future, the energy is turned into vibration. So if you think about earthquake and volcano activity, you will notice that the ground is shaking. The vibration is basically the shaking, either vertically or horizontally. It's not like water. Like when I say water, like tide, think about those. Tide, you can transfer the energy from one spot to another spot. But solid, you cannot. Liquid, even though imagine there's a water level over there, compared to the solid, I want you to look at the structure. As you may notice, it's a little bit loose. Double O, LOOSE. It's a little loose. The reason being is because particles are now have a little bit of freedom. They have a freedom to flow easily around one another. But we have limitation of that movement. Movement is limited. For example, if you have water in a glass or a cup, you will notice that even if there are several hours pass afterward, you will still notice that the water is remain in that container because they are sealed. They cannot go away from that sealed environment. When I say sealed, I'm not talking necessarily about the lid, but this environment over here is what I'm talking about. Liquid does not have its own form. It's shaped based on its container shape and the container change, the form, the, how can I say, the arrangement change. Arrangement can change. And type of the movement, vibration and rotation. As you may notice, this is one of the reasons why, think about the tide. When it comes to water, it's actually going to mix around when there's any type of tide. And next, we're going to look at the gas molecule, the complex one. All right, gas is quite complex. As you may notice, even if I look at each of those molecules, they it's so hard to draw. It's complete random. And to be fair, water move randomly too and collide randomly too. However, gas is a crazy one. You cannot control gas, to be honest. So particles fly in all direction with great speed, and that's a serious part. This is one of the reasons why, for example, and this is a bad example, but I'm going to show you how gas can be dangerous. Imagine when you grill something at the backyard and the gas was open. Even if you may have a neighbor who's, I don't know, lighting a match to smoke outside, that can ignite the fire all the way back to the backyard of um, your house that has leaking gas occurring, because gas can travel so fast. It can ignite really well too, even though it depends on the gas, and at the same time it's unstoppable. We cannot contain it. So I like to say cannot be stationary. That's a fancy way of saying it cannot stay still. And gas does not have its form. And that's something that I really want to highlight. Because gas can change any type of shape, depends on the container. Like water, however, it's even more bizarre. This is one of the reasons why in engineering there is a one called petroleum engineering, the one that study um, gas, oil, those kind of thing, and it is quite complex. Type of movement, it has everything. Vibration, which is what solid had, rotation, which is what solid and liquid has, and translation, which is what gas has. And we are learning math right now. Translation is basically how things can get slide multi-direction. So have that in your mind. So let's look at the water. Water's changing. Water turning into ice, we call it freezing. And by the way, that freezing temperature is at 0 degrees Celsius. Ice can also melt into water. And that temperature, funny enough, it's actually at the same temperature, 0 degrees Celsius. This is one of the reasons why, when it comes to water, this specific temperature, 0, is known as melting point. Water, however, if we boil it, it's gonna turning into water vapor. This is known as evaporation. Other parts can happen too. Water vapor can turn it back to liquid, which is known as condensation. So, if I look at these two situations, you guess it right, those two share same temperature also. But this time, the temperature is 100 degrees Celsius. We call this boiling point. You may heard about that before too. Boiling point. There are some unique physical change too. So far, what we went through is how solid turning into liquid depends on the melting point, and liquid turning into gas, which is done by a boiling point. But there are some that go solid to gas directly. So let's go through this unique example. So, solid and gas. A good example is known as dry ice. It's kind of hard to find out the dry ice in Canada, I found, but you can buy it from an industrial area. But dry ice is basically frozen form of a certain gas known as carbon dioxide. Carbon dioxide. To be fair, uh, you're right, carbon dioxide has a liquid format too. However, I'm going to put that in here. Gas, carbon dioxide gas has solid, liquid, gas form. However, the room temperature is really, really hot. That, funny thing is, solid decide turning into gas directly. There's no midpoint in here. And that's when we call, like how, uh, oh, I just, yeah. I'm just gonna change this wording over here. Can you put that? Dry ice become vapor, or vapor turning into dry ice. That situation we call it sublimation. And other part where the gas turning back into the solid real quick is called deposition. And you can actually find it in some kind of video too. I cannot find it, but in Siberia or in Antarctica, maybe you can try in Canada too. If you have a boiled water in a kettle, put it in a mug, and if the outside is like what, -40 or something like that, go outside and throw that. Then you will notice that it's gonna have a instant snowfall situation. I'm gonna find out and then share that video piece too. It's kind of rare, but it is possible. So that is today's lesson, ladies and gentlemen. Your to-do list is going through textbook page 197, and I want you to solve everything 1, 2, 3, and 4. I believe some of them may overlap from last time, but still, give it a shot.